When we look up at the night sky, most of what we see are stars, small, shining points of light, each one a powerful world of energy. But among these stars lie vast and astonishing structures where the birth and death of stars take place. These structures are called nebulae. Nebulae are enormous clouds of gas and cosmic dust spread throughout the space between stars. Some of them stretch across hundreds of light years and are made of the same materials that form the foundation of all celestial objects. The main component of a nebula is hydrogen, the simplest and most abundant element in the universe. Alongside hydrogen, there is helium and small amounts of heavier elements such as oxygen, nitrogen, and sulfur. Tiny grains of cosmic dust are also scattered throughout nebulae. These dust particles are made of materials like carbon and silicates and play a crucial role in forming complex structures. They can absorb or scatter light, giving nebulae their diverse shapes and colors. Nebulae are not static or lifeless clouds. They play a fundamental role in the life cycle of the universe. Deep within many nebulae, new stars are born. When a region of a nebula begins to collapse, due to factors such as shock waves or gravitational forces, material starts to gather in one place. As the density increases, the temperature rises, forming a hot core known as a protostar. If this process continues under the right conditions, nuclear fusion begins, and a new star is born. Every star we see in the sky today, including our own sun, was once formed inside a nebula like this. Some nebulae glow because of the presence of extremely hot, young stars nearby. These stars energize the surrounding gas, causing it to emit light. As a result, this type of nebula often appears red, a color mainly associated with hydrogen. In contrast, some nebulae do not produce their own light. Instead, they reflect the light of nearby stars and usually appear bluish. Another type of nebula is so dense that it completely blocks the light behind it, appearing as dark patches against the bright background of the galaxy. At a later stage in a star's life, when a star similar to the Sun reaches the end of its existence, it ejects its outer layers into space. These expelled materials form a beautiful, shell-like structure known as a planetary nebula, a name that, despite its wording, has nothing to do with planets. On the other hand, if a star is very massive, its death may end in a tremendous explosion called a supernova. The remnants of such explosions create highly energetic nebulae rich in heavy elements, providing the raw materials needed for future generations of stars and even planets. The colors we see in images of nebulae are not random. Each color reveals the presence of specific elements or physical processes. Red usually indicates hydrogen, blue is often related to reflected starlight, and green or yellow tones can signal the presence of oxygen or sulfur. Although some colors are enhanced for scientific clarity, they are based on real data and offer valuable information about the composition and conditions within nebulae. Today, using advanced ground-based and space telescopes such as Hubble and James Webb, humanity can observe nebulae in unprecedented detail. These instruments allow us not only to admire their beauty, but also to study the history of star formation and the evolution of galaxies. Some nebulae can even be seen with the naked eye or simple equipment in the night sky and have inspired humans for centuries. In the end, nebulae are more than just beautiful scenes in space. They remind us that the universe is constantly changing and renewing itself. From these clouds of gas and dust, stars are born, shine, and die, spreading the elements that make life possible across the cosmos. Every atom in our bodies was once part of a nebula. In this sense, we too are children of those silent and mysterious clouds of space.